Hello, welcome to StatTrek's video tutorial on Advanced Placement Statistics. In this lesson we are going to talk about how to describe patterns in data. Charts and graphs are useful for seeing patterns in data. This video explains how to describe quantitative data in terms of four attributes: center, spread, shape, and unusual features. Note that these attributes should only be used to describe quantitative data, not qualitative data. To illustrate our points, we are going to use a type of chart called a histogram. A histogram is made up of columns plotted on a graph. Here's how to read a histogram. Each column is positioned over the value of a quantitative variable. The height of the column indicates how many observations are described by that value. So in this histogram, you can quickly see that the value with the most observations is 4, and the value with the fewest observations is 7. Graphically, the center of a data set is located at the median of the data set. This is the point where half of the observations are on either side. Here the observations are centered over 4. So you would say that the center of the data set is at 4. The spread of a data set refers to the variability of its data. If the observations cover a wide range, the spread is larger. If the observations cover a narrow range, the spread is smaller. In the figure on the left, data values range from 2 to 6, whereas in the figure on the right, values range from 0 to 8. If we were asked to compare these two data sets, we might say that both are centered over 4, but the data set on the left has less spread, and the data set on the right has more spread. The shape of a data set is described by 4 characteristics: symmetry, skewness, number of peaks, and uniformity. Let's talk first about symmetry. A symmetric distribution can be divided at the center so that each half is a mirror image of the other. Notice that if we split this graph down the middle, each half is a mirror image. But if the halves were not mirror images, like this, we would describe the distribution as non-symmetric. You see the difference. This is non-symmetric, and this is symmetric. Some distributions have many more observations on one side of the graph than the other. Distributions with most of their observations on the left, toward the lower values, are said to be skewed right. And distributions with most of their observations on the right, toward the higher values, are said to be skewed left. Notice that skewed distributions are special types of non-symmetric distributions. Distributions can have few or many peaks. Distributions with one clear peak are called unimodal distributions, and distributions with 2 clear peaks are called bimodal distributions. Symmetric unimodal distributions are called bell-shaped distributions. This particular bell-shaped distribution happens to be short and wide. But note that a tall, narrow distribution, like this, would also be described as a bell-shaped distribution. Any symmetric distribution with one peak is called a bell-shaped distribution. A data set with 0 peaks is called a uniform distribution. With a uniform distribution, data is spread equally across the distribution. Some distributions have unusual features, such as gaps and outliers. Gaps refer to areas of a data set where there are no observations. This figure shows a gap in the middle of the distribution. Outliers are extreme values that differ greatly from other observations. The figure on the right illustrates a data set with an outlier at 10. Except for one lonely observation on the extreme right, all of the other observations in the data set fall between 0 and 4. Okay, let's practice describing patterns of data in terms of center, spread, shape, and unusual features. Using these characteristics, how would you describe this data set? In terms of center, the data set is centered over 4. In terms of spread, the data set ranges from 1 to 7. With regard to shape, it is symmetric with one peak, which can also be described as bell-shaped. And finally, the data set has no unusual features, no gaps or outliers. Let's try another data set. Here, most of the observations are on the left side of the graph. This means that the data set is skewed right. And since most of its observations are on the left, the distribution is centered over the left side of the graph, probably at 2 or maybe 3. The data set ranges from 1 to 7 with no gaps or outliers. And finally, let's try one more example. This is a non-symmetric data set. It has 2 peaks, one at 2 and the other at 6. So it is bimodal. There is a gap at 4, but no outliers. The data set ranges from 0 to 8. And it appears to be centered at the gap 4. You may have noticed that we focused exclusively on quantitative data in this lesson. There's a reason for that. The attributes we've used to describe patterns in data should not be used to describe patterns in qualitative data. To understand why, consider this chart, which uses qualitative labels, red, green, and blue, to define columns. From this chart, you might conclude that the data set is skewed left. However, using the same data and the same qualitative labels, you could produce this chart, which looks like the data set is skewed right. The problem is that qualitative labels, like red, green, and blue, do not have an inherent order. So attributes that rely on order, like symmetry and skewness, are not meaningful with qualitative data. These attributes should only be used with quantitative data. Let's summarize. Graphic displays of quantitative data are commonly described in terms of 4 characteristics: center, spread, shape, and unusual features. The center of the distribution is located at the median of the data set. The spread of the dataset refers to the variability of the dataset as indicated by its range. The shape of the dataset is described by four properties: symmetry, skewness, number of peaks, and uniformity. And gaps and outliers can also be useful in describing patterns of data. In addition, we introduce some terms to describe the shape of common distributions. Unimodal distributions have one peak. Bimodal distributions, two peaks. Distributions that are skewed right have most of their observations on the left. And distributions that are skewed left have most of their observations on the right. And finally, a bell-shaped distribution describes a symmetric distribution with a single peak in the center.
That's all, folks.